Hello everybody, today we will be going over a midpoint and parallel lines problem at the IB Math Studies level. So the problem gives us the diagram that shows this straight line L1, which intersects the x-axis at the point A, 6, 0, which would be right here, and the y-axis at point B, 0, 2, which would be right here. And so for part A, we need to write down the coordinates of M, the midpoint of line segment AB. And so a midpoint is, as its name suggests, the middle point between two lines, right? So in this scenario, it's probably going to be like just around there, all right? So that is what a midpoint is. And the midpoint formula, which is in the formula booklet, is as follows. In a set of points of x1 plus x2, which would be like the beginning and the end of the line, divided by 2, this is going to be my x value, and my y value is going to be y1 plus y2 divided by 2. So notice this is in the same format as a set of points like x comma y, just that my x is written like this and my y is written like this, all right? So in that sense, this formula is suddenly a lot less scary. The next kind of hard part is defining what is my x1, what is my x2, what is my y1, what is my y2. And since I have two set of points, 6, 0 and 0, 2, and this is the beginning and end of my line, I simply have to define which one is which. And so I will define that 0, 2 is going to be my first set of points. So I'm going to say that this 0 here is my x1, and this 2 here is my y1, and my 6, 0 is going to be my x2 and y2. This is completely arbitrary. You choose which one is which. I chose to do it this way because the 0, 2 shows up first on the line. It's more on the left side. But again, as long as you're consistent, you can do it whichever way you want. And so I'm going to plug in these values for the midpoint. And so I end up with my x1 being 0 plus my x2 being 6 divided by 2, comma, my y1, which is 2, plus my y2, which is 0, whole thing divided by 2. And so doing a little bit of math, we end up with 6 over 2, comma, 2 over 2, which gives me the set of points 3, comma, 1. So that is how you use the midpoint formula. It's very important that you define the x1 and y1 and the x2 and y2 respectively, and that you are consistent. So that is for part A. The midpoint is 3, comma 1. Moving on to part B, we need to calculate the gradient of L1. And first things first, gradient is just a really fancy way to say slope, all right? So don't be scared when you read gradient. Just remember that it means slope. And so what is the slope of the point L1? Well, we know from the formula booklet as well that the slope is equal to y2 minus y1 divided by x2 minus x1. And the reason this works is because this, another way to describe this is rise over run, right? And so just visually speaking, looking at these 2 points, what we analyze when we look at slope is the rise over run that it has throughout its course in time, right? Throughout the graph. And so we know that it is going, clearly it's going down, so my slope has to be negative, okay? And so each one of these little triangles that I drew here is showing my rise over my run, okay? And so if I plug in these values here, that is essentially what I'm replicating. I am doing one big triangle to find its rise over run. So that is why this formula works. And so plugging it into my slope formula using these same values for x2, y2, x1, y1, I end up with the following. I end up with my slope being y2, which is 0, minus y1, which is 2, over x2, which is 6, minus x1, which is 0. And so my slope is going to be negative 2 over 6, which is equal to negative 1/3. And notice that before I even finish the formula, my rise here is negative, right? Which makes sense because all of these rises, all these little triangles that I drew, have a negative x aspect to it, and all the positive ones, and all the runs have a positive aspect to it. which makes sense to when we analyze what our um, slope function gave us. Okay, I'm just mentioning that because I think it's important to understand why all of this even works in the first place. And so that is how you do part B. Finally, for part C, we need to find the equation of L2. And they tell us that L2 is parallel to L1 and that it passes through the point 3, 2. Okay? And so if we know that it's parallel, what does that mean in respects to the slope? Remember that parallel lines look something like this. Okay? And so parallel lines never touch. Okay? They have the reason that they never touch is because they have the same slope. If two lines which look very similar and you might say, oh, these never touch. Well, as long as their slope is just a little bit different, they will touch eventually, okay? So the only time when they do not touch is when they are parallel. And so if they're parallel, they have to have the exact same slope, okay? So what we know about L2 is that it shares the same slope as L1, which is my value from part B, which is right here. And we know that it passes through the point 3, 2. Now, since they want it in the form y equals mx plus b, we can literally plug in all the values that we got. And so we know that we're dealing with a slope of negative 1/3, and we know that we're dealing with a set of points 3, 2. And so if I plug that in to the form y equals mx plus b, sorry, plus c, we know that my my y is going to be 2, right? Because it's this value here. My m is going to be negative 1/3, and my x is going to be 3, and we will find out what c is, right? So we're doing this to find out what c is and have a more complete function. Because right now, um, we need to find m and c to have in y equals plus c form, right? And so since we're missing c, this is the way to get it, and m, we got it in part B, okay? That is why we're doing what we're doing. And so if we work this out just a little bit, we end up with 2 equals negative 1 plus c. So we find out that c has to be equal to 3. And so if c is equal to 3 and m is equal to negative 1/3, we can see that my line in the form y equals mx plus c is going to look like this. It's going to be y equals negative 1/3, which is my m, x plus c being 3, because that's what we just found. So this is how you do part C to find the equation of L2. There are other ways to do this part. The other very famous way is to use the point slope formula, which looks like this. Y minus y1 is equal to m x minus x1. And so if you feel more comfortable using this, well, go right ahead. You have your set of points from right here, because they give us that it's 3, 2, and you have your slope right here. And so if you do the math behind it, you should and you will end up with the same answer, okay? So those are the two main ways to solve part C. That being said, with these kind of problems, just make sure you are consistent, okay? Be consistent with which one is your x1, which one is your y1, which one is your x2, which one is your y2, and it should all work out fine and dandy. So, um, that is how you do this problem, and I hope it helped.